So we'll give folk another 2 or 3 minutes. And good thing we waited, because a whole bunch more people are showing up. Uh-huh. That's a good point. If folk wouldn't mind, actually, even if you would mind, please scan the QR code so that you know, are recorded as having shown up. Mostly this is so that they continue to give us an actual room. If we don't, we will not get a room in the future, and then we will be sad. Wow, more people are arriving. Thank you, Jared. Where is the queue gone? Where's the queue? Hello. Do you remember how I find the queue in the new UI? Okay. Is Naomi in the room? Or Chime? Yeah. I just want to make sure that these are the right slides that I have for. Um, no, but that would be entertaining. Number resource organization, number resource, RIR. Alrighty, everybody. I guess let's get this thing kicked off. Actually, Brian Carpenter is joining the queue, just so I can make sure that I can see the queue. I can't find the queue UI. There it is. Okay, thank you, Brian. Does appear, and I just hadn't seen it because I'm dumb. Anyway, hello, everybody. This is the IEPG meeting at IETF 119 in Brisbane. Hope everybody slept well and is well rested and didn't wake up at 2 a.m. and 3 a.m. and 3:10 and 3:15, etc. So what is this IEPG thing anyway? It is a informal gathering that meets just prior to the IETF meeting, and it's supposed to be a set of presentations and talks about things that are operationally relevant. For a long time, that largely seemed to be BGP and DNS, but we have a somewhat wider selection of things. This is our agenda. We have a couple of presentations. Um, the update on IPv6 and DNS truncation behavior is actually joined together into a single presentation. So, it's actually one less than this, but same content, just one presentation instead of two. And any questions, agenda bashing first? Nope. In that case, without further ado, Sophia will talk to us about the NRO RPKI program, and I will try and get the correct set of slides up.
Will I see them there too?
Confirm your selection. Oh, well,
that's all right. That's all right. Hello, everyone. Good morning. Thanks for coming to the other side of the world. I know some of you may still be recovering, depending on when you landed. I'm Sophia, for those of you who don't know me already. Since early January this year, I'm the new NRO RPKI program manager. And since I've been gifted with a few more minutes than I originally thought I had, I thought I would introduce myself because it's been like 10 years since the last time I attended an IETF meeting. And so some of you may remember me from back then, and I'm sure there's lots of new people as well. So until December, I was working in HR for APNIC. So because of that, because of the pandemic, because of becoming a mom, it's been a few years that I've been a bit disconnected from the technical world. And as part of promoting this new program that I will be talking about today, I wrote a blog article that was published a few days ago through the 5RIR blogs. And the blogs have an author profile, and I had to review my bio. And I had this kind of philosophical moment and a bit of nostalgia of who I used to be when I realized that those bios were very out of date. One of them said that I was martial artist, vegetarian, and I'm none of those things anymore. So I had this moment that I realized I'm not who I used to be. So I did this a bit of a disclaimer. If you remember me from 10 years ago, I'm still me, but I'm not who I used to be.
Looks like the mic might have stopped. I don't know. Try bang on it. We'll tap on it, which makes people annoyed.
But that's stable.
Yeah, here we go. We can take this one, and I will get me Echo to bring us here. You can just hold it in the thing.
Okay. Let's see if I don't break anything here.
And while you're doing that, I will try to turn on the display.
Oh, wow.
Should be batteries back there.
Oh, this will be my workout for the day. It's quite heavy. Okay. That's fine. That's fine. Don't worry. Didn't I say I was an amateur singer? I was used to holding microphones. So I was saying, I'm still me. I'm not who I used to be. Those things that I mentioned have now been replaced by amateur nutritionist and expert at dealing with tantrums, and a sleep addict, but most of the time in withdrawal. So bear with me. Oh. That's much better. So bear with me because most days I haven't had a very good night's sleep. I think that's enough about me. What do I use to change lights? This one? Okay, so next slide, please. What I will be covering today is a brief introduction to this new NRO program, what we're trying to achieve and how we are planning to achieve it, who we are when I talk about us, and a few minutes for questions if there are any. Next slide, please. And I'm talking about NRO, assuming that some of you know what it is, but I thought I would include one slide about what the NRO is. The NRO is the Number Resource Organization that brings together the 5 regional internet registries to achieve that mission of actively contributing to an open, stable, and secure internet. Next slide, please. And why this program is important before I talk about how it was actually created. We are aware that there's currently some diversity in the way that the RPKI system has been implemented by the different RIRs. There are inconsistencies in the services that are offered, in the way they are offered. There's some inconsistencies that have been identified and documented. So for example, there's a manners document that lists some requirements and standards for operators of the RPKI service and includes this annex that I know is very old and it's actually outdated. So probably one of the things we need to do is share with Manners updated information on whether RIRs are compliant or not with those different requirements and standards. But this was just to show an example of inconsistencies that have been identified and documented. You can also see in the documentation of CRIL, when the description of interacting with parents, there are differences on, depending on what the RIR that the parent is, yeah, the interactions will be a bit different. So you have the source there for more information. But basically, we are aware of those challenges that this may be presenting. And next slide, please. The NRO is aware. And in 2022, the NRO went through a strategic review process. And one of the outcomes of that process was an agreement to work to focus on a more robust, coordinated, and secure RPKI service. And as a consequence, this RPKI program was created. Should I wait or no? We're good. This new RPKI program was created. And as I mentioned, I started this role early January this year. And as I understand it, where we could contribute the most is helping with removing barriers or the obstacles that mostly those organizations, network operators that are interacting with multiple RIRs to create RPKI objects may be experiencing as a consequence of the inconsistencies that I mentioned. So next slide, please. What we're trying to achieve, the purpose of the program is to provide a more consistent and uniformly secure, resilient, and reliable RPKI service. But in particular, we've been working on agreeing what are the more specific outcomes that we could start working towards. And that's what we have agreed on. So it's basically those entities that may experience difficulties because of inconsistencies, because they interact with multiple RIRs. We're hoping they will be able to do so through a single spec interface. We will be also working on improving the transparency of the robustness of the system, enhance security consistency. That's another area of inconsistency nowadays. And finally, and this presentation is part of that last outcome, is keeping the technical community informed and engaged throughout the program, and also when there are concerns raised, that we can respond in a coordinated way. Next slide, please. And how we're planning to do that this week, as the steering group, and I will share with you who the steering group is, has flown from different parts of the world, and for the first time we're together in person, most of us. We will be taking that opportunity to meet in person, and we will be having some sessions brainstorming what are the initiatives that we could work on this year, and prioritizing based on value versus effort. So doing an estimation of what's the effort that it would require to execute those initiatives, and whether it is worth that effort if the value that we could offer is high enough. Next slide, please. When I say we, I refer broadly to the product team, but to the program team, sorry. But in particular, as I mentioned, I will be working directly with that steering group. So the program team consists of the Executive Council of the NRO. They are the executive sponsors, and I am the program manager. But the stars of the program team are the RPKI experts from the different RIRs. So the steering group has representatives from the 5 RIRs, and we will probably also be working with other subject matter experts from the RIRs that also work in the space of RPKI. Next slide, please. I know that you probably know some of the names here. Some of them are actually in the room if you want to raise your hands. Tom, Mark, Brad, I'm just naming the ones that I know are in the room, Tim, Felipe. So most of them are quite active in IETF, and so I know you know them. These are the guys that I will be mostly working with. Next slide, please. And as I mentioned, I started in this role early January, and I've been trying to catch up with where things are at because I have been away for a little while, and a lot has happened in the last 10 years or since I kind of lost touch a bit with the technical world. So one broad question that I would like to put out there for anyone who would like to answer it for me, and doesn't have to be today in the room, but feel free to reach out to that email, is what are those main barriers or obstacles that we could contribute to, that we could remove or improve in some way through better coordination and collaboration among the RIRs. But in general, if you have any ideas of initiatives that you think we should consider, also please feel free to reach out to that email address and we will listen. And next slide, please. If you would like to know more about this program, I have updated that RPKI page in the NRO website with some information about the RPKI program. At this stage, is pretty much the same that I'm sharing today, but we are going to use that page to keep the community updated on what we're working on. So with time, we will include the specific initiatives, or also if we have specific requests for input from the community, we will also do it through that page. And as I mentioned, there was a blog article. I included the URL for the one at APNIC, but the 5 RIRs through their blogs posted a blog article with some information about the program as well. And that's it from me. Thanks everyone for your attention. If there's any questions or comments, I would be happy to hear from you guys.
Job Snyders from Fastly. Thank you for stepping up to this job. In my personal experience, the RPKI ecosystem can be a bit stressful to work in. There's lots of opinions, some backed by academic research, some by operational experience from ISPs, some from operational experience at the RER level, and navigating all those stakes is, I think, quite the job. So I wish you the best of luck and welcome.
Thanks, Joe. Yeah, spend the last couple of months catching up with where things are at, trying to understand those like big challenges, and also trying to understand who the players are. And there's like so many, and with such a variety of needs and concerns and realities that, I mean, I was prepared for the job being a bit challenging. So no big surprises there, but yeah, I will rely on the help and the participation from all of you guys, all the people involved with RPKI work, because I'm no expert. Anyone else? Any questions? Any comments? It's good to be back. I was hoping a queue of questions or tomatoes, but happy not to see that. That's it then. Thanks.
Great.
Thanks,
And
everyone.
I just wanted to say thank you very much for doing this, and also apologies for the technical, going first is always entertaining. Oh, we have a.
Well, I do have a question now, if I don't have to get it on my head here.
I'll hand you the mic.
Hi, Tail. Now, since you've mentioned it, why were you expecting possibly tomatoes?
Oh, I don't know. Because I was like, I guess during the recruitment process last year, I was prepared, like, I got so many like warnings and like, so that you know, and I guess I was prepared for the worst. But it's nice to see happy and friendly faces and be positively surprised. So yeah, thanks everyone.
And Teo, come to a cider ops meeting, and then you'll understand.
Maybe that's why.
So next we have Niaoni, I believe, who is going to be presenting on IPv6 extension header comparison. I don't remember the exact title, but it's in the agenda. Interesting. Apparently it's going to be a great presentation with disco lights. There we go. Um, so how to implement IPv6 extension headers, a comparison. Is that, okay, there we go. So I just want to confirm these are the right slides, right? These are the ones you sent? Okay, cool. And I will give you. There we go. As I said, disco. Let's give you this mic, which should work better. Apparently, yep.
Hi, sorry. I'm Nalini Elkins, and Chinmay and Amog are going to talk about some work that we've been doing for the past couple of years on eBPF and extension headers.
Sorry. This is the root ops alert that goes off when they do the root ops testing every whatever.
Yeah, hi everyone. Hi everyone. I'm Chinmay. So we'll be presenting briefly about performance evaluation of an implementation of an extension header called PDM in eBPF and kernel. This is the overview. We'll be talking about some eBPF concepts, and we'll be talking about extension header, the PDM implementation in eBPF. And we have done performance analysis of the eBPF implementation and the Linux kernel implementation of PDM. Next slide. Why we chose eBPF for our implementation? There are two other ways that we could have implemented this. So why eBPF over a Linux kernel implementation? It is easier to implement in terms of development times, and there's way less maintenance involved. And also it's very portable, so we can port it across kernel versions without having to worry about dependencies and any changes made to the kernel. There is something called the BPF verifier, which lets us create safe programs that can be run in the kernel. We don't have to worry about the kernel crashing or anything. It makes sure that there are no infinite loops and things like that. Also, the accuracy of timestamp captured is related to PDM. PDM is performance and diagnostic metrics, and it uses timestamps in order to calculate network latencies and packet processing latencies. So there are eBPF hook points that are executed before the kernel network stack is reached. So that lets us capture via arrival time and via arrival time in a much more accurate way. Also, why eBPF over raw sockets? All we have to do in eBPF is we just have to make space in the fully crafted packet, and then we have to add our extension header. Also, we don't have to modify existing user space applications, as we are using the kernel stack completely. We are just adding an extra program that inserts extension header into each and every packet. Next slide, please. Coming to TCBPF. TCBPF is an eBPF hook point in the traffic control subsystem in the Linux kernel. So it's a subset of eBPF programs that is attached at the queue disciplines level. So it can be attached to both ingress and egress. So as opposed to XTP, which can only be attached in ingress. And it has better packet mangling capability than XTP because we have the escape buff, which allows us to perform various packet related operations. It's not good for complete packet rewrites, so it's better if we just do something like a minor modification to the packet, like changing a field or inserting an extension header. Next slide.
And this now works. Yeah. Oh, we fixed it somehow.
Coming to the implementation of PDM using TCBPF. So PDM is performance and diagnostic metrics. It's described in RFC 8250. So it's a destination options header. It's used for measuring packet processing latencies, packet processing and network delays. So we can attach to both ingress and egress of an interface, and that is especially important for PDM. because we are capturing timestamp in the ingress, and we are using that to calculate certain fields in PDM. So yeah, we've used BPF helpers, which are certain API that is provided for packet mangling in eBPF. And we use something called eBPF maps to store the 5-tuple state, so we can communicate between the ingress and the egress program using these eBPF maps. Over to Amog.
Yeah. Hey, everybody. We benchmarked this eBPF implementation with another kernel implementation. So this is heavily dependent on the implementation itself, but I would say this would represent something like where eBPF hasn't been like optimized a lot compared to the other implementations. So we checked on three things: CPU cycles, network throughput, and packet processing latency. CPU cycles, we simulated network traffic using IPerf, and we would measure it using perf. And we had a test setup like with two VMs with 16 cores and 16 GB RAM each. And network throughput, we just directly measured the IPerf throughput that we got. And packet processing latency, we used ftrace in the kernel stack to get the individual runtimes of each function. Yeah, so the CPU cycles, we got both for eBPF egress and eBPF ingress programs. We have two of them. And we can see it performs an order worse than the kernel. We'll talk about what exactly was this. So we were able to get a flame graph, and memory operations were actually taking a huge chunk of that CPU cycles. So we think it can be optimized. We'll talk about it in future work. Then, uh, yeah, so the PDM kernel implementation, that's the egress that we are talking about. So we compare that with the egress program. Yeah, network throughput. We see that, without PDM, it is much, we have a higher throughput as we would expect. We're not doing additional processing. And for PDM kernel, we see that there is a slight loss of throughput, but compared to eBPF implementation, it does perform slightly better. And eBPF implementation, we saw it was using a lot more clock cycles, and hence we would expect some amount of affecting to the network throughput, and we see that here. So eBPF implementation performs marginally worse, but nothing too bad. Yeah, this is packet processing latency, and how we would implement, reinterpret this table is the first line, the PDM kernel implementation, that is a direct measurement of the function in the Linux kernel that we implemented that directly adds the extension header. So it shows the approximate latency for the function runtime. But for eBPF, we are not able to directly use ftrace to get that. So we are using a function that then calls the hook point. And so we have measured both with the eBPF program attached and without the eBPF program attached. And hence, for each runtime of the eBPF program, we subtract both of them, and we compare 1.28 microseconds, which is the egress packet processing latency of eBPF, with the PDM kernel implementation. And kernel is around 0.7 microseconds, and eBPF takes around 1.28 microseconds. This was obtained using ftrace, and that's also heavily dependent on scheduling and the VM scheduling and the other environment, in the test bed. The ingress packet processing latency is also around 0.5 microseconds. Yes, and this is what we plan to do in the future. We plan on optimizing the eBPF program to find out where the limits are and how well this can be pushed, because eBPF offers a lot of flexibility that isn't there in kernel, and we would like to see how well this could actually perform. Uh, What we think is we are doing a bunch of BPF SKB reads, which might be taking up all of those memory-related CPU cycles that we found using the flame graph. We also would want to do how this eBPF program performs in high-performance computing environments, since we were just using consumer-grade machines to test this out. And then we would also like to implement and analyze other extension headers in eBPF, how well it would perform something like hop by hop or some other destination header. And we would like to see how eBPF is flexible or good enough for these extension headers as well. Yeah, that's about it. If there are any questions, we'd like to hear from you or any thoughts.
Lorenzo Coliti. I mean, this actually, I mean, this looks like it's fine, you know. Compared to in production environments, changing the kernel is this generally like this multi-year effort, right? In theory, it's something you can do in 6 weeks, but then you find out that in practice, you know, like you qualify a new kernel version and there's regressions and so on. I would guess that the inefficiency here is because you have to move stuff around, right? You run after the IP header has been written. And so you basically have to shift, right? I'm not even sure like how you do that. Like how do you rewrite the IP header? Because you've got to like create space at the beginning of the packet, and then you got to put your extension header before the payload, and then you have to like probably like copy the IP header. Right?
Yeah, actually it's made easier using, there's a helper function in the kernel written.
Oh, there's a helper to like insert something?
Yeah, we can create space immediately after the IP header.
But you still have to move stuff around because you've done it once the IP header is already written.
Yes.
I see. So that helper is probably not very efficient because and you probably incur the cost of cache misses. Basically, it's, yeah. I wonder if you can do something like use an LD preload thing to like create a destination extension header and basically cause it to reserve the space, and then you just overwrite it instead of moving everything around. I don't know if it's just like as a hack, you know, if in a closed environment, it might work. But yeah, this generally looks like it's fine. Did you publish the code? Like, is it somewhere where people can look at it? It looks quite interesting.
Yeah, that's also a discussion that we'd like to have. We have not yet published it yet, and along with a preferred license, we'd like to do that soon.
Great. I had a quick question. I'm just going to drive your slides because I can. So in the throughput test, it was like 18 gig per second. I'm assuming that that's with like fairly large packets. So was that with an internet mix of traffic?
Yeah, we had a MSS size of 1000 set.
Okay.
But the MTU was 1500. Okay. This is because we would have to check each time in eBPF because we are adjusting space in case we increase it above the MTU. And so we didn't want to do that.
Cool. Great. Thank you. Great. Any last questions? Don't see any. Awesome. Thank you very much.
Thank you.
And next up, we have Mr. Jeff Houston. Where is DNS ready for IPv6? And let's discover if DNS is ready for IPv6. Seeing as it's Jeff, probably not.
Cool. Thanks. Good morning, all. My name's Jeff Houston. Yes, no, whatever. Okay. The reason why I'm kind of asking this question is that there is this RFC, which the title and the body just don't seem to gel. So in this RFC 3901, and it is now 20 years old, younger than V6, but only just, which it actually is titled V6 Transport Operational Guidelines, where it kind of says, don't drop V4. You know, it really is saying just keep V4 going, which anomalously was the guideline in 3901. It's kind of, for God's sake, don't drop V4. Fine. As a V6 transport operational guideline, I suppose that was an accurate piece of advice. But, you know, someone spotted this only last year, and they're kind of going, really? And so there is a draft out there, Momoka, it's not Momoka-san, what's the female version? Momoka-san was in Prague saying, look, we need to update this. And the update, 3901 bis, recommends, you know, in normative language, that there are at least 2 NSs which are dual stack, which if you think about it, is a world ahead of what we were saying 20 years ago. Just keep V4 going, don't care about 6. This is kind of going, well, you should do something about 6. And there's even a should, there at least should be one V6 reachable in the authoritatives. So the kind of thing that I see in that is sort of, if we are going to be serious about V6, you know, let's take it seriously. And it's not saying keep V4 around, it's largely the opposite. You should really be equipping DNS infrastructure with V6. And indeed, thinking hard about V6 only. And the assumption behind this latest draft, which I'm sure some of you in the room and some of you out there on the net kind of agree with as a general proposition, you know, is that V6 is now mature. I'm like, Christ, 30 years. How much more mature do you want? It's now in its dotage, technologically speaking. And it's so well mature that transport for the DNS is one of the easiest tasks in the world. It should be efficient. It should be fast. It should be just as good as V4. And you kind of go, really? And some of you might go, oh, yeah. And some of you might go, oh, no. I thought I'd measure it. And there are kind of 3 questions, I think, that are relevant to this. And the first is actually a question around, we really are relying on happy eyeballs. And we're really relying on an architecture of transition where in a dual stacked world, you always send the first packet in 6. The reason why is that in a large and diverse network, you never know when to turn off 4. There's no clear signal. If you always prefer 6, always, then at some point you might look at your network going, well, everyone's doing 6. There is no 4, and it gets turned off automatically by that preference. And so behind happy eyeballs was actually an experience we went through. Does anyone remember DECnet? Thank you. Does anyone remember how it died? Because all the users at the time preferred to use TCP, you know, and DECnet just slowly died. There was never a switch off moment. There was just no one using it. And the same theory is kind of applying here, that if you do happy eyeballs, V4 will die if everyone's dual stacked. That's just the way happy eyeballs is meant to work. So the question is, in the DNS, not the web, is this true? You think. Or, if that's not true, is there a bias the other way, or is it just random? So that's the first question. Do you have more questions, Lorenzo?
Why do you assume that happy eyeballs means that the other thing will die? It's probabilistic. In the presence of enough packet loss, the old thing will always be used.
Well, the issue is if there is packet loss in V6, you need to fix that because you'll still have V4 around. In other words, always packet loss. You pessimist. There's no packet loss. We build perfect networks. Yeah, right. Bite my tongue. Yeah, we're all professionals, at least for the first 2 minutes. The other thing, which is kind of, well, okay, let's take this one step further. Let's drop dual stack and simply place an authoritative server on V6 only. And let's see in today's internet, how many users will get there and actually get an answer. And thirdly, because quite frankly, in my view, addresses don't matter anymore. Routing doesn't matter anymore. The entire trust, authenticity, and security infrastructure of the entire internet is name-based. You know, name-based certificates, name-based everything. And quite frankly, the web PKI, this is the web PKI. If we really want to make this better, we actually need to make that binding tighter. of authenticity and names, and the only technology that's available, in this universe currently is DNSSEC if you want to improve things. So it's a useful question to go, well, if we ever got to that mythical state of using DNSSEC and V6, does this work? So those are the three kind of questions that I had here. And this has given up on me. You got batteries anymore? Next slide. Oh, sorry, back slide. I think that was a real slide, wasn't it?
That one?
Oh no, how does it well support large UDP? Next slide, yeah. Next.
You try your button. Okay.
Right. The DNS, for those who have poked their nose in, is bloody odd. It's worse than bloody odd. Only folk in this community could have invented it. And the abuse of terms is stunning. We all talk about resolvers. Nobody knows what a resolver is. Is Google's 888 service a resolver? Because the common language says, oh yes, of course, it's a resolver. It's not. It's a whole family of resolvers. So is it just my platform at home? Well, that's a resolver too. But there's a difference when I want to talk about resolvers, because you're trying to talk about resolvers that matter somehow. And that gets really hard, because in this day and age of resolver farms, of sort of large services where the actual engine is distributed across many platforms and there's some weird form of synchronization, or maybe not, between them, to be perfectly frank, we have no idea what a resolver is. So if you want to talk about the DNS in terms of resolvers, I think you've kind of caught the rocket ship to Pluto immediately, because you're inventing a reality that the rest of us don't understand, because none of us understand resolvers. That's the first problem. But there is another problem. We don't understand queries. What the hell is a query? And it sounds kind of silly, but if you think about it, when I ask for a name to be resolved, my question doesn't get passed to a point of authority for that name. Does not. My question goes to my front end recursive resolver, who goes, that's a good question, Jeff. Let me hold that to one side and I'll ask a question on my behalf, no reference to the originator, and go and ask that question. But why ask just one when I can ask 2 or 3 or 10 or 100? And quite frankly, queries just fan out. It's not a single TCP transaction. It's just a mess of stuff. So again, when you have queries, you've got to understand that queries is this sort of amorphous concept that just multiplies like crazy. There is no such thing as a query. There's a lot of them. And the DNS is now basically AI. It's taken a life of its own. And if you pulled out a query from the DNS logs, as here's a query, why is it here? Nobody knows. It's just queries. It's weird. So we try and measure this stuff. And the way we try and measure it is actually from the edge looking in. So the measurements from the user experience. And so when we talk about how many people do this or how many people do that, we're talking about users, not the count of resolvers, don't know what a resolver is, and not really the count of queries, don't know what a query is. And so the way we do this is any of you not seen this slide? No one put their hand up. Good. You know all this shit. Good. Moving on. There is a lot of noise in the DNS. 46% of these unique names we generate in the ad system, I'm the only authoritative server at the other end. 46%, I see 2 or more queries from a single known seed query that enters the DNS cloud. So the DNS kind of naturally goes, look, 2 queries is better than 1, 3 queries is better than 2, and it just goes on and on and on. One query, there's, a non-negligible amount that actually I see 10 follow-up queries in the first 10 seconds. If I'm prepared to back that off for a few years, I will still keep on seeing these unique name queries because I put the timestamp in the query name amongst other fields. So A, the DNS never forgets. B, if anyone really wants a massive storage device, just use the DNS. Write, query, read, listen. It'll come back to you. So there's a lot of noise in the DNS, and quite frankly, 46% of all queries are 2 or more. Average number of queries, about 1.7. So the DNS is extravagant. It's UDP, send 2, send 3, send 20, what the hell? So now we get into this question, the first one, dual stacked. How does it work? Now, don't forget, I'm measuring users, not measuring resolvers, not measuring queries, I'm measuring users. And the way this would kind of work, the authoritative server always answers no tricks, not making it any harder. And I'm looking at, for each unique name, single-seeded query coming in, what were the characteristics of the queries I saw at the authoritative? Were they only V4? 1, 2, 3, 10, whatever. 43% of the time, only V4. Were they only V6? Well, that's only 11% of the time. Those queries that came in were only coming in on 6. And the rest was a mix, 46%. Now, if you kind of thought, do they prefer to use V4? They might, but why is it only V4? Interesting. So this is around 500 million queries done late last year. So less than half of all those resolution queries show dual stack, even though I'm dual stack. Okay. Does it do happy eyeballs? Well, no. Quite frankly, when I get a bunch of addresses that I can query for a name, the DNS implementations that people use for recursive resolvers, bind, unbound, or power DNS or anything else, all of them seem to go, here's a bunch of addresses, pick one, pick another, keep on picking until I find an answer, don't care which protocol. Mark, is that true? No. Good. Wow. Wow. Whoops. I want the laser. If bind had a dominant market share, that green column would be at the top. No, it's fascinating. I derive from that data, there is no bias. And if you're telling me our I only have one server. If you're the recursive, there's only me and you in this room. You know, if the V6 path is completely AWOL, then okay, but no, V6 paths aren't that anomalous.
Mike, please.
I was going to give him your mic, but
Mark Andrews. The other thing, of course, is that a recursive server doesn't know the round trip times when it starts. So,
a priori, no.
Yeah, and we just choose a random small value, just so we spread the load around a bit. But we do actually bias IPv6 servers. It is on by a couple of milliseconds.
Great. I thought bind was pretty common. I think we all assume that. And if that's the case, the way this experiment worked, that does not show in a marked bias. 21%, no, 20%, 20%, 23%.
You've got a lot of Google out there. You've got a lot of Quad 8 and Quad 4 and...
No, I don't.
And Quad 1's coming
through not too. Really, oddly enough. In these kinds of experiments, Google is not that dominant. Yeah. Google's around 10 to 15% market share. Cloudflare's around 5%. The rest you really can't see. So this is a whole lot of ISP resolvers.
And there's a long tail.
Whatever. But you see what I'm saying? There's no visible preference in the behavior of resolvers. I take on board what you said about bind, and now I'm scratching what's left of my head and my hair. You know, it's sort of, this is weird. But it is no solid signal. And this is the next one, which is a really hard slide to see and interpret. But I look at the first two queries that I see at the authoritative, and I've got a timer going. There's a packet capture. How long did it take for the second query? Now, there are a number of UDP-based timers in various implementations. Someone runs a timer of 370 milliseconds, someone at 400, someone at 800, someone at 1 second, and those are the peaks. Those colors, which you cannot see, vary V6, V4, V6, V6, etc., and they're not distinguished. It's not that V6, V4 is spaced this way and the other ones aren't. The behavior of resolvers seems to be protocol independent in that second query. Dees.
Yeah, you have a mix of two experiments here, right? On one hand, you are benchmarking the performance between resolvers and your measurement platform over V4 and V6 and the DNS behavior.
You're talking about resolvers. I don't know what resolvers is. I am benchmarking the outcomes between users. This is an ad-based system. I'm not looking at the infrastructure. Lucky you get one of APNIC's ads. Congratulations. Don't click. I pay more, or Google do. And I'm looking at the behavior as you see it from you compared to you and you and you and you and you. So I'm not benchmarking resolvers. I'm benchmarking the experience of the end user, right? Yeah. Subtle distinction.
But when you then look at the query logs you see basically paired measurements between whatever approaches your DNS server.
Everyone gets a unique query name. Lucky you.
Yeah.
So if I see the same name, I know it's you. Because a different query name is a different user, a different ad. So that's how I can string together this sequence of queries from you, if you were lucky enough to get an ad, right? And that's the timing that you're seeing here.
Yeah, so that does include if the path towards wherever your platform is 100 milliseconds slower over V6, that ends up in here as well.
I can't see how long it took to get that query to me. You know, unfortunately, or maybe fortunately, you don't give me control of your browser. Maybe you should, but you don't. All I see is the packets that come at my end. I cannot tell you how that query got to me, what recursive result. I can tell you what recursive resolvers you end up using, but I don't know delays or anything else. I don't know why, but this is the behavior that occurred between the first two queries.
Clear.
Cool. Jared.
Jared Mach, Akamai. I'm wondering if there's actually a behavior difference based on the user agent that you see. So I'm wondering if there's something interesting in the browser libraries and how they go, especially since a lot of the browser folks seem to think that they know how to do DNS better than the DNS libraries.
I reckon
which might be right or wrong, by the way.
I reckon on Thursday, the 5th of April, 1990 or something, some guy said, let's do browser signatures. And the very next day, someone said, I'm going to lie. And,
sure.
And the browser signatures are really noisy, incredibly noisy about finding what browser am I talking about. So I have not spent time looking at those SIGs.
Okay. I was curious if you'd see the similar.
I don't know. It's actually a hard one to correlate. I have sat here and all this work is just the DNS queries, not the follow-up web. Lorenzo.
Lorenzo Putti. Am I misreading this, or is this just too damn smooth, right?
Log scale, everything is smooth in a log scale.
Oh, I
There's
see.
a massive back off. But what actually amazes me, and this thing up here, there's an astonishing amount of back-to-back. And it's kind of, I sent a query and I don't even care what happened, I'm sending another. And the DNS is extraordinarily extravagant in those first few milliseconds of just going, I'm impatient. I'm just going to snow the world with queries. And it's really prevalent. And the only one that actually spaces out is if I send V6 and another V6, it actually spends more time before it sends the second V6. Whereas all the others, it kind of, so I don't know what behavior that is, but they're within 10 milliseconds. It's not even waiting for an answer. It's just going to ask.
So, okay. So log scale, yeah. So that's definitely something I hadn't thought of, but then why are the peaks so low? The retransmit should be much higher, right?
I always answer. And I'm kind of anycast. I'm not brilliantly anycast, but I'm close-ish to most users. And there's no tricks. I always answer.
Right, but like the peak at 800, right? If there's some common implementation that has a fixed retransmit timer,
at 400, there is. Someone can put their hand up.
But that's still kind of low, right?
Yeah, Microsoft was 1 second. Because most of the time I answer, so it doesn't need to requery.
But that's like, oh, I see.
You're right. I'm not withholding answers, and I'm not playing with you. in that respect.
So it's
not
100,
yet. That
so
comes
it's
later in
100
this pack.
times less than the stuff on the left, right?
Yeah. So this is all a very fast decay. But what I wanted to show was, the stuff in the far left is kind of weird and I don't understand. Some of these recursives just, the resolution engine just goes fonk and sends out 2 or 3 packets without even thinking. It's kind of, gee whiz, I love packets, send me more. God knows why. And then you see the retransmit timers going, packet got dropped. Jen.
Jen Linkova, I'm not sure I'm surprised, maybe I misunderstood this, because if you run Wireshark on your laptop, what some browsers do, you get 3 resolvers you received via DHCP, RDNSS, whatever, right? And you try to resolve a name, your browser will send packets to all of them, close the circuit after the first answer, and then send ICMP port unreachable to the rest of them. So you will see at least 3 requests for the same name, ideally in this case, right? Immediately, right? One after another.
No, the stub resolver is normally more polite.
But it's different resolvers, right?
No, but when you've got multiple resolvers in execresolve.conf, you'll ask one question to one answer generally. There are variation. Once you time out, you might ask 2 queries to 2 different. You might go 3. It's sort of paced.
Now, what I've seen in TCP dump browsers ask all of them immediately and then drop answers from 2 out of 3.
Is this a browser you're running? Why are you running this browser? It's, this is weird behavior. It kind of...
It is not a browser, it is DNS mask. It has this option where you can configure it to send either to one or to all the resolvers. And so it will, when you configure it to send it to all, it will send it to all. So if it has 2 resolvers, it'll just spray. And when it sprays across all of them, you'll see some
I always thought it was
latency.
an economic failure that we answered DNS queries for free.
That's what it does. But DNS mask is extremely popular.
We should charge for answers.
Yeah. I mean, there's other implementations, but DNS mask is extremely popular among home gateways. And if it's configured in this way, it'll send them to all its servers. And so it's not an aggressive retransmit. It's just like, I'm just going to send
crazy
it to all of
coding.
them.
Yay. Thank you, DNS mask. The DNS community just love it. Okay.
Hi, this is
Queries are
Nalini.
free. Yeah, sorry.
This is Nalini. Now, okay, maybe I'm totally not following you, Jeff. It's completely possible. But I mean, seems to me like if you do DNS, DOH, DNS over HTTPS, you're going to get happy eyeballs. Am I missing something?
I'm not doing that. This is just UDP.
No. I know.
This is measuring, this is not measuring what if.
Yeah.
This is looking at what is.
If clients are using DO.
The client might be doing DOH.
Client could do whatever it wants. This is the view from the authoritative
Right,
server
but if the
coming in from the
client-
recursive.
But if the client asked twice, the recursive might say, well, the client asked me twice.
I'm just going to stack the
transmit the second one as
right.
well.
So, I am looking at the point where I can see. And quite frankly, there are very few recursive resolvers that give me all their logs because, why would you do that? And so, yes, this is the view from the back end of the DNS. And even there, the multiplication is, I think, still worrisome. It's just extravagance. So my conclusion is, bind notwithstanding, there is no visible evidence of a happy eyeballs-like behavior that comes out of these numbers for whatever reason, right? And so I'm heartened to see that bind does it, but it's kind of, whoa. Is there a reverse bias to use V4? There seems to be, because the next set of numbers kind of go, there's still an awful lot of folk who go, well, V4 seems to work best, so I'll just use that. So let's have a look at this by actually now biasing things a bit. This server will only answer in V6. It's the authoritative server. The recursive needs to get to me using V6. There were 45% of folk who only gave me queries in V4. 35%, in other words, 10% less, will never query me if I'm Z6 only. So 51 million over 5 days in this experiment, 65% got me in V6 because that was the only way you got an answer. And the others, one third of users were then stranded on a V6 only. So, oops. Comparing the two, that's the dual stack mode where you see 43% in V4 only and no query at all, 35%. So when you kind of compare the two, there seems to be this apparent bias. Now, don't forget, I always answer. I don't withhold things. I don't choke up. It's just in the second one, you've got to ask in 6 and I'll answer. If you ask in 4, there is no answer. It's just silence because you could never have got there. The name server does not have a v4 address. There's nothing. So it appears that about 2/3 of the network would see your domain name if it was served from v6 only from the authoritative viewpoint, and the other 1/3 would not. Oops. And then we add DNSSEC because, you know, v6, packet fragmentation, and DNSSEC. Now, as we all know, there are only really 2 major changes in the v6 architecture. And one was this thing about the extension header and moving fragmentations out of the standard header in v4 into an extension header. And the second thing is, don't fragment is jammed on. There is no such thing as fragment enabled. A packet on the fly can't be fragmented. You've got to go back to the source going, you've got to do it yourself because on the fly ain't going to happen, which involves a bit of ICMP, packet too bigs and all that kind of stuff. You know all this. So the DNS and DNSSEC kind of today rely on fragmentation because when you ask who uses it, the root zone of the DNS will show you that if you just ask for the DNS key resource record for every single record in the root zone, there are a bunch of folk, thank you Slovenia, who say, look, I'm going to send you 3,319 octets of answer because you look as if you need it. There are a whole bunch of these which are massive. 300 of those entries in the root zone. If I take 1,500 as the point at which, no matter what you're doing, fragmentation will happen, 300 of those GTLDs out of, what is it today that's active? 2,000, 3,000, somewhere around there. 300 kind of go, if DNSSEC is going to work for you, you've really got to handle something about large packets, okay? So this is not abstract and it's not academic. This is kind of, if you want DNSSEC to work, you're going to have to do this. Thank you.
I think this is what it's telling you is that DNSSEC is abstract and academic. I mean, the reason why it's okay to send packets that are 1,500 is it doesn't need to work because nobody cares. I mean, it would be nice if it did work, but in practice, you know, packets more than about, I don't know, usually 1280 have
There is an entire conversation about the comparative qualities of the web PKI and the inability to revoke certificates and the entire mess that is today's secure infrastructure, cough, cough, laugh, laugh, versus what you could do with DNSSEC. And I think that's a fine conversation because in some ways the crap we've got now in the web PKI is crap, but it's the only crap we have. And you know, DNSSEC could feasibly do a better job, but if we keep on going, we're just not going to use it. I think you're slamming the door a bit early. But you can keep on slamming it.
No. I think, for example, I think it is required by standards not to work because ICMP messages must be rate limited.
You're right, and it's kind of, this is a problem, right?
So
no.
Maybe I'm wrong. Yeah, Mark, maybe say those.
What Jared said, let me repeat this because it's worth repeating. Nobody designed this whole internet thing to work together. And you know, wow, if that's a discovery, welcome to the IEPG.
Mark Andrews here. We did actually put API hooks in there to tell the stacks to fragment at the network MTU back in 1999. Now, if your DNS vendor hasn't set that socket option, or Linux,
so Mark,
or Linux refuses to do it by default, it hides it away behind a hash ifdef. I'm not POSIX.
Right. So Mark, in the next few slides, we're going to determine how many folk don't listen to you.
Yeah.
Okay. And we're going to put a number on this.
But fragmentation on UDP
doesn't work.
No, over IPv6, the server that is responding should be fragmenting for you. There is no timeout if you've written your name server correctly.
So again, if this is
a sec, we might have lost.
We're diverting.
We might have lost the external. Can somebody external let us know if they can still hear? Looks like the network might have bounced for a sec.
I think Mark just said it's
okay.
Cool. So if you don't know this, there's a whole bunch of interesting reading you should do. Fragmentation is a problem in V6. It just really is. And so if you're trying to rely on the DNS and fragmentation, I'm pressing the next button, Warren. Can you just flip it forward?
Yep.
Right, so can I measure it? And the answer is, well, that's really easy. But I'm not going to disobey you. If you set a buffer size to go, don't send me big packets, I won't disobey you. I will fragment or whatever as you need. I'll truncate, I will obey your instructions. So let's measure it. Next slide. Online ads, same thing. Unique name string, same thing. Authoritative server, same thing. But it's a big answer. It's deliberately pushed out. Next. Total number of tests, 32 million. Failure rate, 18 million did not get the answer. And I know because I'm doing this in the glue. So you kind of set a trap for the DNS going, you need to go and ask this next domain. It's a referral response on here's the name of the name servers, but I'm not going to tell you their address. The only way you can ask the next query is if you resolve that name of those name servers, and I'm going to send you back a big V6 packet. And you can only ask the consequent question, resume what you were doing, if you actually successfully received that big V6 packet. So of that 32 million, 56% of users were going, didn't get it, just abandoned. There was no way I can resolve that name. Now, like I said, I'm not pushing the envelope. I'm not disobeying. If you give me an EDNS buffer size, I will stick to it and truncate. I will go to TCP if that's what you want. But that number is, awesome. Awesomely bad. Thank you, Mark.
Jeff, does your name server actually fragment by default at network MTU? That's different to EDNS buffer size.
I fragment by default at my interface MTU,
but
and that's standard behavior.
We had no. UDP has a socket option to say to fragment at 1280, regardless of your network MTU, your interface MTU. If your network interface MTU is 1500, it'll fragment at 1280. Have you turned that on in your name service?
No, I'm running standard stuff, Mark. I didn't listen to you. Like the rest of the world, I wasn't listening. I was just pulling it out of the box and running it. So
we have.
So let's now
do this.
Let's now look at what you can do about this, because I agree you got to take this seriously. This is just awesomely bad, because V4 to back up V6's failure is not the long-term answer. It just isn't, right? So we've got to change this appalling drop rate, and it is appalling. So do you work around it or you fix the network? Maximum payload in the original DNS spec, 512, right? It was the maximum amount of fragmented packets that could be reassembled by a compliant host. We added extension mechanisms. We allowed, in fact, we said in 6891, well, fragmentation kind of works everywhere. Let's say we can assemble fragments that go up to 4096 octets, and everyone used it. So the issue is if it's that much bigger than what you say is the maximum size, I sent the truncate bit and we return over TCP. Once we run TCP, the answer gets through. So if you can fit it, fine. If you can't fit it, truncate. V6, of course, has to go back to source, ICMP. We've said all this. So the issues are V6 messages don't always get through, ICMP6 messages. They can't be validated. They are just messages. You have no idea if it was your packet or just someone just sending you ICMP because it's a Thursday. Anycast makes it worse because the paths are not necessarily symmetric on every hop. And of course, no one likes fragmented packets in security firewalls because. And so you've also got this lost response and timeouts, and timeout ranges, times out, 400 milliseconds to a second. So there's all these kinds of issues. So generically, I've been looking at fragmentation drop rates across the entire internet. And the story is kind of less than good. once I got the experiment working right at the middle of this year, I'm seeing sort of a global average around 20-25% of fragmented packets from users on the ad to my servers, Anycast sort of close to them. Around 25% of packets never make it. We'll see that it varies country by country, implementation by implementation, network by network. The V6 implementations in Australia are relatively clean. The server I'm using is against Singapore, but the drop rate's tiny. The V6 implementations in China are impressive. That's the one in the top left. That's the one that's swinging to, I can't even see from here, 50-60% drop rate. India, good. Japan, not so good. So it's not even the original code, it's kind of how you surround your infrastructure and the kind of packet filters you're using, etc. That folk use different infrastructure and they treat fragmented packets differently. So it's not an internet-wide number, it's kind of network by network, bizarrely enough. So you can't count whether fragmented packets make it or not. And if you're writing DNS software, it's kind of don't fragment really, because you just can't. If you're running a DNS, maybe as a server, you just should never send a packet larger than 1232, irrespective of the stack, irrespective of your kernel settings, just never send a packet larger than 1232, right? Or say to your clients, you know, UDP is a mess. It's a nightmare. The web proves that you can do all this stuff basically over TLS. Let's just put the DNS over TLS and get rid of this nightmare. UDP was an old idea. We're over it. Or you take an idea from Davey Song a few years back and just send an additional response together with the big fragmented one that's truncated. If you didn't get the first one, here's one that tells you to use TCP. Oh, that's an extra packet. Didn't we discuss at the start of this session that DNS mask sends extra packets gratuitously? Let's send another that says, if you got this one first, or if you didn't get the other, just use TCP and get out of my hair. Kind of could work. The RFCs actually say this if you pick other RFCs. UDP usage guidelines 2017, what it really says is, for God's sake, don't fragment. Just do not. Don't even think you can get away with it. Don't. So you can fix it. You can fix the entire network and make fragmentation work. Well done. You can change V6. I'm like, apart from mucking around with the interpretation of the flow label, what has the IPv6 working group been doing for the last 30 years? So, you can change V6 because it's an option. Just change this stuff. George.
So, Jeff, we've talked about this several times, and the observation I want to make is that 5 to 10 years ago, if you'd stood up and said, let's move DNS to a TCP transport, the queue would have been 25 deep.
I know,
with
it just went
DNS
plunk.
operator saying, impossible! And I am not sensing that the DNS community wants to pretend it couldn't use TCP.
There is this theory that the only real user of UDP is the DNS. And the only real issue is we can't do source address validation. And if we move the DNS to TCP, we could get rid of UDP from the planet. There is no microphone line. I've still got some slides to go, but as long as you're having fun, I'm doing fine.
Jeff, that was cute, but incorrect.
Fine. Or we can cook the pig. Just basically change the application, because as we all know now, networks are irrelevant, applications matter. So you actually bias the application to avoid it. So what do? In the long run, you could just walk away from UDP, and it would not be a bad decision in the long run. But we're kind of stuck with what we're doing. And realistically, MTU discovery, recursive to sub-recursive and recursive authority, the overhead's too high for casual UDP. It's just, you don't amortize the cost of MTU discovery against the consequent packet flows. So in some ways, you've got to think about this elsewhere. And the best way is to actually truncate the thing and going, look, I don't care if it's you either get the answer in the size available, that's not fragmentation, or use TCP. And there's a DNS flag day to say that. Is anyone listening? Here are the offered EDNS 0 buffer sizes of resolvers that talk to me, weighted by query volume. There's an awful lot, 46%, who are kind of going 4896. Someone's not listening. Someone is just not listening. It's kind of, yeah, I can do big packets. You can't. You really can't. But 46% of users sit behind resolvers and go, yes, I can. And they're lying. Lorenzo.
How could it possibly know the truth, right? Like it depends on incoming routing, which is,
Oh, the truth is fragmentation doesn't work.
Yeah. Oh, that they could know. Yes.
Right.
The
That's the
problem is
truth.
the problem is if fragmentation doesn't work, which it doesn't, we actually have no plan, right? As you point out.
Yeah, right. So we'll get into the whole truncation thing. But, my conclusion from this stuff is in today's network, as it currently stands, we're back to 3901. You really need V4 to push up the problems that V6 can't handle today. We are not ready for IPv6 only. It just isn't good enough yet. And there are various ways that we could do it, even at the server mode going, I will not send fragmented packets. I don't care what you think you can handle. It won't believe me. And that's a fine answer. But this then actually asked or got me thinking about truncation. Because the answer is you truncate the packet and go, let's just do TCP. Yeah? And so the next question is, fine in theory, but what about practice? So if I send you a perfectly formed answer, got an answer section, a glue record, not fragmented, it's a good answer, but I set the truncation bit, will you use it? And it used to be, and there was certainly a theory, that large amounts of resolvers simply biased for speed. If I had enough to work with in the answer, I didn't care about truncation, set sail and let's just do this. How well have we sort of moved beyond that? And if truncation is set, it means TCP. And the next question, which is equally one to ask, is, well, use TCP, really? How many folk actually sit behind resolvers that can? And the answers, oddly enough, for do I use the answer if truncation is present, is astonishingly good. In V4, 0.239% of users sit behind resolvers that go, I don't care if it's truncated, I'm going to use the answer. That's across 67 million or so. Oddly enough, China and Chile, every single ISP in Chile goes, good enough for me. Weird. In V6 only, oddly enough, the answer is better. It's almost as if it's more recent code. And there's just no code path that goes, well, it's an answer. I don't care about truncation. I'll just use it. So the answer in V6 is actually better than V4 about, I don't care about the truncation bit. I'm just going to use the answer.
And we have a long queue. I don't know. Do we want to trade
I'll
the
be
queue now
almost
or at the end?
finished, so I can see it, and I'll come to the end of this. So the worst offenders, in China Unicom, Guangdong province, 25% of users go, an answer's an answer, guys. I was just going to use this answer. That number's so big, it's not random. It's a definitive behavior. The other numbers are small. And the next question, can you next slide me, please? It's gone stuck again. Right. V6 only. Interestingly, there are a number of resolvers in Univision, which is a big provider in Mongolia, goes, yeah. You don't see it in dual stack because they prefer to use 4. But if you go 6 only, the problem rears its head in Mongolia, Nigeria, and China as being prevalent. But you don't see it because of dual stack. You only get this exposed in V6. And the next one, can't do TCP. The opposite. Almost everyone in the V4 or dual stack world, because it is dual stack, kind of go, yeah, you tell me TCP, you give me truncated, I will visit you in TCP. And the folk who can't, really small pool, 0.77%. V6, it rises to almost 3% of users can't do TCP if it's V6 only. Huh? Different implementation? Of course not. Over-enthusiastic security firewalls? More than likely. Let's have a look at who they are. Dual stack can't do TCP. Bharti Airtel, 8.9%. Telefonica Chile can't do TCP, 76% of users. This is definitive. They don't do TCP. So there's a bunch from Chile, a bunch from China, and someone from the Ukraine. I'm almost over. Can you wait for a second? Stay there, but V6 only. And this is what leads me to believe it's a firewall. Telstra, 35% of users can't do TCP, and they're running a dual stack network. I'm like, they're seeing me in TCP. I'm giving them truncated, and they go, no, not going to do it. V4, fine. V6, broken. They're not running a different DNS resolver. They've just got an enthusiastic firewall that says TCP port 53 is evil in V6. Wow. Pakistan, you can see the list as well as I can. And I think that's kind of where I got to. Is there another slide there, Warren? Because this thing's gone dead on me.
Nope, looks like that.
No, there's Randy behind. So at this point, if there's a big queue, and I'll start with you in front of me because you're in my face, questions?
So is this TCP the thing that I'm seeing, this problems? Is it because of your firewall thing, or is it because TCP doesn't do well over wireless or something like that?
No. This is all, in my opinion, this is all about firewalls, not implementations. This is all about folk forgetting to enable port 53 TCP in V6.
TCP works fine for wireless, so there's no problems.
No.
And what was your name for the mic?
What was your name?
Priyanka.
You're right. The web wouldn't work if TCP didn't work, you know.
Thank you. And the queue goes Rich, Lorenzo, David, Andrew, and Jeff Haas.
Rich Sauls, Akamai, DNS neophyte. On the IP fragmentation stuff now, or UDP fragmentation not working, there's a quick solution available that handles it. I just wonder if you'd look at that, or if you know a priori why it's too expensive compared to TCP.
Why
it wouldn't work compared to TCP, right? It's just a user space UDP application that handles large messages.
It possibly doesn't. You know, structured measurement is much different to an application somewhere with a few users. And the DNS is so pervasive, and there's enough V6 around that this is a broad scale measurement. And what it's really pointing out is in that broad scale, pushing large fragmented UDP around this world in V6 does not have a good track record.
Sure, I understand, but Quick will do its own fragmentation.
Oh, you're talking about Quick?
Yes.
Okay, so let's talk a little bit about Quick and let's understand what we're talking about just for... Yeah. I set up an encrypted session, stub to recursive resolver. The overheads of setting up that session can be amortized over the next billion trillion queries that you make. It's as efficient as UDP in the long run. Recursive to authoritative, you tend to smear your queries everywhere. The overhead of setting up the session dominates the cost. And so moving from UDP, bang, bang, into hello, here's a question, here's an answer. God, I've got nothing more to say to you, goodbye, kind of sinks the DNS into, why isn't the DNS working today? And that's why recursive to authoritative is this kind of elephant in the room about, are we stuck with UDP? And I don't know that we know what the answer is. In fact, I'm sure we don't know what the answer is.
Thanks.
And we've only got about 8 minutes left for this, so.
Yeah, sorry, I've hogged a lot of time here.
So we just to make sure I understand, you believe that this works in IPv4 because of fragmentation, right?
This stuff is just truncate to TCP, and it works in dual stack.
You use something that's rare, it doesn't work. That's the internet. Okay, so no,
well, it's not meant to be rare.
My question is, why does it work? It works in IPv4 because of fragmentation, right? That's what.
Oh, in fragmentation in V4, if I'm pushing large answers in DNSSEC, we don't notice the horrendous failure rate, no. So it seems to work in V4. Okay. I did not give you measurements on that V4 only.
I think we basically just discovered that, you know.
V4 works.
No, it's worse than that, actually. So there is, I mean, I don't see any path forward other than basically giving up and allowing sort of extension header mutation and making fragmentation work the same, because the only other solution that you have is to turn this thing into a stateful thing where you can use Quick or something. By the way, why does Quick work? Because it's got this 1300 byte packet at the beginning.
Correct,
right?
Lorenzo. And part of the question is sort of lurks behind a lot of these conversations is the web seems to work on a stateful, quick, TLS-based environment.
But the web doesn't do question and answer thing that requires 1 RTT responses. That's the thing here, right? Anytime you try to move this to Quick, you'll hit, you'll basically take latency, you'll change it to 3, 4, 5x because you've got all of these handshakes, right? Maybe we need to do this. Maybe we need to do this.
Once as I said, the context is stub to recursive, it actually looks viable,
Sure.
right? Recursive to authoritative is the issue. And it's kind of, we need to do something there. And TCP.
But latency matters for that too, right? If you
Right,
introduce...
but TCP and truncation seem to offer answers without the overhead of a long setup and then so that's why this is important.
No, it's at least 2 RTTs, right? That's also a non-starter.
Well, the issue is I've got to waste 1 RTT to get truncation. I've got to waste 1 RTT to even do basic TCP. So it's only the 3rd RTT that gives me the answer. This is why Davy Song's mechanism was actually interesting, because it sent back 2 answers. First RTT said, if you got this answer fragmented, run away 1 RTT. But in the same RTT, I've got a signal that says, if this is the only answer you get, jump to TCP and avoid that wait. So the truncation comes immediately straight on the answer, right? So it was marginally faster.
By the way, the reason that TCP works is that we have MSS rewrites. Maybe we need something like this for UDP, because it doesn't actually work. It just works because the network can mess with the MTU, right? Which is maybe what we need here.
Or add fragmentation back into V6.
Or actually fix the name so it's fragment that network MTU.
Mike.
We're running out of time here.
But
And fun as this
on
is.
that particular point, though, TC and its behavior under TCP and falling back to TCP is orthogonal to the whole fragmentation issue.
Yes.
So, I mean, we still want TC to work independent of whether fragmentation is happening. Additionally, I wanted to say, to expand on Warren's answer a little bit, is UDP is used in a hell of a lot of things. You just mentioned Quick over and over again, but also VoIP and online gaming. Like, there's a lot of uses of UDP out there that are not the DNS. And finally, I was curious about what methodology you use to tail, by the way, I don't think I said when I stepped up.
Sorry.
For measuring the TLD response size, because it was interesting, but I was like, what the heck is going on with Slovenia? And so I checked it out, and the situation is either better than what you said or worse than what you said, depending on what your measurement is. Because
DIG plus DNSSEC.
Well,
of the DNS
Slovenia
key.
always, for any query, always returns.
Not
with DNS.
any, the DNS key.
Oh, okay. It was the
So
DNS
I was
key
actually
response that you were
playing
looking
the
up?
role of being a validator.
Okay.
At some point, I need to extract their
Right.
DNS key resource record. And as I pointed out, some of them are just bloody big.
Right. And so for a normal DNS delegation, though, the NSR said it's a pretty reasonable response size.
DNS
But if
keys
you ask
normally are
any,
reasonable.
If you ask
On-
any, it's almost 6,000
No,
bytes.
no, 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 no.
No, I'm just pointing
Yeah.
out that it's even worse than that in some instances.
Who asks any other than DDoS people?
Not in a practical.
You're right.
Andrew Camping, 419 Consulting. Just reflecting on all the issues that you highlighted, Jeff, in the presentation, seems to me the only reasonable conclusion is we need to retire V6.
I'm waiting for another microphone line, but we've run out of time. So I'm going to leave that one just, as we say, pass to the keeper in a cricketing analogy.
Jeff As, mine's not that entertaining. I do TCP a lot. Most of my TCP sessions live much longer than like a second or so. So I'm used to asking much weirder questions on the opposite side. They keep on saying, let's use TCP here. It's been years since I've had to do things like admin web servers, that sort of thing. Web servers are an easy example. DNS is even worse if you're having these short sessions with all sorts of lingering TCP state. One of the things that you sort of said earlier in your presentation is out of the box. How do you make TCP behave well for DNS servers out of the box for all of these very short-lived sessions and very lossy environments?
And that's the issue with the recursive to authoritative, that you've never got a long train of consequent queries. It doesn't seem reasonable to leave the session open. You want to cut quickly because there's no more questions on the whole.
So I guess
stub to recursive, new ball game.
I agree. And what I'm sort of trying to highlight is we can't hand wave TCP as the solution for these sorts of things, even though that's what the specs are giving us right now.
We can fly the kite.
We could also get electrocuted by the clouds. But let's recognize you're identifying all these things that push us to TCP also are going to push us to having TCP explode without something else tuning it.
I suppose the point of this talk is, in some ways, we didn't, as Jared said, kind of design it all together in one big hit. There's a lot of various components going on in this particular architecture, and the DNS exposes a lot of it. And piecing it together exposes some of these fundamental trade-off issues. And in some cases, we kind of go, let's all do V6. And it's sort of, wow, dual stack kind of pulls us out of some problems that V6 only encounters. TCP is hauling us out of problems when UDP freezes up. You know, so it's those kinds of trade-offs that we're trying to chart a course around. And I don't think there's a textbook on how to do it. You know, there's enough variation in behaviors that you're on your own.
So a parting comment, I agree with everything that's been said. We're almost identifying what we really need is a new transport that is intentionally short-lived for these types of applications.
I thought we needed a new standards body to write some standards profiles to get us out of this mess, because the IETF's doing such a good job. Oh, sorry, microphone line again. I didn't say that.
Can you take this to V6 Ops? Because it's an operational problem that needs to be fixed. Can you?
No, I will be presenting this, or I have asked for a slot time for not the truncation bit, but the whole V6 thing as an operational issue. I think it is V6 Ops squarely and firmly going, it's not DNS, it's actually V6 Ops here. How can we get over this problem? If you really want to make more extensive use of V6, you know, that's what we need to do. I've abused my time. Thank you very much.
Excellent. Thank you very much, Jeff. And now we will have Randy, but let me just make sure that I have the correct set of slides here. Randy had updated his slides. Randy, do these seem to be the latest version? I did click refresh, but sometimes it gets sad during the presentation.
We won't know till the end. This is going to be fairly quick. Props to Ashutosh, who actually did all the heavy work. I just kibitzed. Slide. So, of course, this is about BGP. Trying to get a little view into V6 prop in the graph. Chose route views. Chose the multi-hop collectors because they give a wider eyeball. Went back 20 years. Took about 3 samples a month and then tried to select non-glitchy ones. And then we chugged through all the AS paths as pairs, pardon me, A, B, BC, CD, etc. So picking out all the pairs, cleaning it up, like ignoring prepends, ignoring non-singleton AS sets, etc. Slide, please. So just to know that our measures are about right, Jeff has studied this far more deeply and frequently. So we just wanted to know about how many prefixes, and it's close to Jeff's measurements. So we're probably measuring the same animal. Slide, please. Okay, so this is the number of ASs in V4 versus V6. The bump, as Jeff has identified, is CERNET in 21. He's got a good presentation in the PDF. That link will actually work. Rather disappointing number of ASs we have here. Next. Boy, something's funny, but anyway, this is the edges, in other words, the BGP links, which are only in V6, not in V4. And you will notice the nice steep increase, but considering we're pretty much in a dual stack universe, you've got to wonder what those are. Next slide, please. That's what I'm afraid of. You skipped a bunch of slides. Backwards, backwards, backwards.
This deck only lists 7 slides. Do you want to just present from your laptop? Because
sure. If I can figure out how to do it.
There we go. Randy asked to share the screen. grant screen. It'll take, I click the button. Hopefully it's letting you do stuff.
Let's see, which button do I click?
I do not know.
All slots for the media are already taken. You have to take yours down. There we go.
There we go. Thank you. And Brian Carpenter might also have to share from his machine in a bit because it looks like it didn't import them.
Uh-oh.
I will also look and see if I have a different slide deck at the same time.
Do you see this?
Yes, we do now.
Okay, much better. Let me just figure out how to get full screen. And I tried that. There we go. Okay, so we've been here. Number of prefixes looks something like Jeff's. The number of ASs, not exciting, but see some things. The number of inter-AS links. This is, we really thought these were converging, and in fact, they're diverging, which is kind of depressing. This means, and this may have some relevance to what you were measuring in V4, Jeff. Oh, pardon me, in V4, V6, and reachability. Sometimes you can't get there from here. Okay, as I said, the number of V6 edges. That's an interesting question. And that's it. Short presentation. Jeff, you could have gone longer. Hans Kuhn of Raufuse was very helpful. Matt Rowan of Uni Adelaide, with whom we've worked a lot, is coming on board to do much more work here. And Alexander also helped. So that's the story.
Do we have any questions? Hopefully we do.
And you can escape.
Everybody is resigned to being sad about this, I guess.
V6 is sad. There was a quote in something I read the other day of, I'm sorry, go Lorenzo, who?
Yeah, Lorenzo, wouldn't you expect the edges to go slower than the links anyway because it's quadratic instead of, if you have AS like
edges are links.
No, sorry, like you have this graph that shows that like the number of ASs that are deploying, that one is lagging back. So if that one's lagging back, then the edges are going to be quadratic. It's going to lag back even further, right? You have the percentage of the number of V6 over V4 ASs is less than 1. So if you do basically, if you assume n squared, like they talk to each other some percentage of the time, you'd expect the edges to be like even worse than the number of ASs. But yeah, I agree, it's a sad story, but just.
What's interesting is they looked similarly sad. The divergence is about the same in edges versus vertices. I can show those slides again, but you've all got them on your laptops.
Okay, well, thank you very much. And we have a bonus presentation from Brian Carpenter. For some reason, he did upload the slides and I did approve them, but they're not showing in the list. So he will just share his laptop screen.
Okay. Well, can you hear me for a start?
Yep.
Can you see me?
No picture.
That's strange. Oh, hang on. Yeah, well, now you can see me. Isn't that a thrill? Right, so I press ask to share screen. Yeah. Do you want to share screen? Yes. Select window or screen. Did that work?
Not yet. It says a screen share is being started, but maybe it's a
Okay.
connection issue.
Wait a minute. Here's another thing. Allow meeting.
Brian had also emailed them to me, so I will see if I can find them in there in case screen sharing doesn't work.
Okay. I think I found the right thing to click.
There we go. Great.
Okay, so you still see it?
Yes.
Because I've gone to full screen, so I can't see what's going on. Okay, this will be very short. And I want to show you how to make Firefox visit an IPv6 linked local address. And by the way, I get out a lot about IPv6 brokenness as a result of doing this. Step 1, run a little thing I wrote called select.py, Python program. It says enter the IPv6 linked local address and interface. You type it in. You might deduce from what you see there that it's on Windows, because the zone identifier in Windows is just the number, %24. Then select says I'm sending the unsolicited MDNS response, and test.local should now resolve as that completely arbitrary linked local address. People who've been following the saga of linked locals in browsers will realize that this is a contentious issue. Step 2, you run ping test.local. It finds the right address and it pings it, and it gets a reply in 1 millisecond since it's just about a meter away from the computer. So you've successfully persuaded MDNS that there is a thing called test.local with this particular linked local address. Step 3, try Firefox with HTTP test.local. Here you need to read the small print because the small print says the connection was reset. The connection to the server was reset while the page was loading. That actually tells you that Firefox has sent an HTTP message to that particular linked local address and has been told to go away. Believe it or not, I cheered quite loudly when I first saw that on my screen because it's the first time for about 1,000 versions of Firefox that it's been possible to contact a linked local address from Firefox. That's it. The context for this, for people who are completely mystified, is a couple of drafts that will be discussed in 6man and HTTP bis, respectively, and a GitHub reference there to where the code is. What I didn't put on the slides, because I didn't have time or space, is that that works on Windows. It doesn't work on Linux. It doesn't work on Linux for a variety of reasons, which add up to brokenness due to IPv6 being something of a second-class citizen, due to the code that's involved in MDNS not doing quite the right thing for dealing with linked local addresses, even though MDNS is supposed to work for linked local addresses, and so on. And I've written up the tale of woe on the Linux case on that GitHub repository there. So basically, that was it. That's all I wanted to say, and I can stop sharing at this point.
Thank you. Any questions?
I wouldn't really expect questions. It's just I wanted to make the point that you can make your computer do things that it doesn't want to do. You can make browsers do things that they don't want to do, but there's weakness in the system. You know, it echoes a bit of what Jeff was saying in a completely different department, except, by the way, the story on resolving in hosts when MDNS is involved is even more complicated than for cases where you go straight to a real resolver, whatever a resolver might be. I'm done.
Alrighty. Well, thank you very much. And I think that that brings us to the end of IEPG at IETF 119. Before everybody leaves, I would encourage you to start thinking about what you all want to present at the next IEPG in Vancouver in 3 months' time. Maybe more things about how great IPv6 is working?